Hello everyone, welcome to today's episode of 5-Minute Machine Learning. Today we're playing with data visualization using the Matplotlib module in Python. Matplotlib is a comprehensive library that creates data visualization in Python environment. This video is a basic tutorial of how to create simple line charts, scatter plots, bar charts, and simple animation. Most of the material in this tutorial can be found in the Matplotlib.org official website. The code will also be available in GitHub, link in the description below. Without further ado, let's get right into it. Okay, the first thing you do is import NumPy and Matplotlib. And if you're using Jupyter Notebook, you would like to make sure you're going to use this Matplotlib inline function so that the pictures you generated appear right after your code. We're going to generate some numbers from 0 to 10. I'm going to create a canvas, an empty canvas. And we're going to add axes to this canvas. 0011 here simply means the left and bottom point and also the width and height of the axis. So don't worry about that. And we're just going to plot x versus its squared value. And we're going to label it as x squared. For the legend, you can specify the label name and title here. Last but not least, you could have the legend function for the legend. Location 0 means you would like Python to automatically decide the best location for your legend. Otherwise, you could also manually decide the position of it. Also, I would have my legend to not have a frame. So there you go, your first simple line chart. Now this looks a little bit plain. How can we decorate it a little bit? Now the first thing you can do is that you can alter the figure size by giving it the canvas size, the resolution. Here DPI simply means dots per inch. So the higher this number, the higher the resolution, and also whether you want your canvas to have a frame. Next, we're going to create a list of colors. So Matplotlib has some predetermined colors. You could use some letters to express your colors. You could also use some hex color code to represent the color of your choice. And if you're not sure what the color code is, just simply Google hex color, go to any color, and then copy the code here. Here we create a little loop. We're going to loop through all the colors. So for color in colors, we're going to create a gap equal to the index number of the color. And then we're just going to plot x and its square minus 10 times the gap. So let me plot this first. So there we go. So here gap and label are some values that's going to be different for each line, and basically we're plotting 8 lines here in the same canvas. Line width could be adjusted as well as the line style, and then label here is the label we created above. Also we would like to have our legend placed at the best position. You could customize your title, the font size, and bold or not. You could do basically whatever you want. Next, you could also alter the line style. Let me plot this first. So we have 4 built-in line styles. And also you could use your customized line style. Basically you can do any pattern you want. The next thing you could do to a line chart is to alter the marker type. So here the same old trick. We have a quick marker style bank. Plot this. You could customize your marker as well. For example, you could choose the size of a marker. So here the same loop, we just loop the size from 1 to 10 exclusively, and then we're going to plot multiple lines with different size of markers. There we go. The face color of the marker could also be customized. So here again we're looping through the rainbow colors, and then we're going to specify this marker face color, and marker face color is going to be looping through the rainbow colors. Sometimes you would like to have multiple outputs. You could use subplots function for that purpose. So here we're creating a 1-row 2-column subplots of size 14 by 7. Notice that 0 here indicates the first plot, 1 here indicates the second plot. So for the first plot, we're plotting x versus its exponential value, so it's going to grow exponentially. For the second plot, it's plotting the same content, but here we're setting the scale to logarithmic scale. Also, we would like to have a grid, which has a color of blue, transparency of 50%, line style of dashed, and line width of 0.5, which is very thin. As you can see, two plots, one on the normal scale, one on the logarithmic scale. Alright, so much for the line charts. Let's look at some simple scatter plots. If you just want to have a quick dirty scatter plot, you could just use this one line code, plot.scatter, and it will generate some very simple scatter plot for you. And if you would like to customize it a little bit, so here we have some random numbers. They are random numbers from a standard normal distribution, and then we're going to create a color, which is basically just the difference between them, and then we take the sign of it. So you would expect a periodic color change. Using the same scatter function, you could set the transparency to be 30% so that it looks nice. Next, for some simple histogram, first we create some random numbers. Again, we have a mean, a standard deviation, and also some random numbers. And then we're going to specify the number of bins, create the canvas, and generate the histogram using the hist function. Also, if you want to add a best fit line to your histogram, you can do so. There you go. Something special about Matplotlib is that it could generate animations based on the dataset. For example, if we run this block of code, we will get a simple animated line chart. For that, you're going to need the matplotlib.animation, and then you're going to need a func animation from that. The idea is that in the func animation function, you would like to have your canvas and your animate function. The animate function is your customized function, which basically loops through the data input. Another interesting animation I'd like to share is based on the scatterplot function. So here, what this chunk of code is doing is to mimic the raindrop in a little pond. So here you're creating a canvas and you want to specify your canvas face color to be white. Also, you want to have your number of rings, and then the ring position will be randomly generated using NumPy uniform distribution. Also, you would have your ring colors to be set from 0 to 1, and eventually it disappears. Here you have your customized update function, which takes this position, color, and size. So the last step is to call the func animation function, which calls your figure function and your update function. And if you're interested in the detail, I'll put the link here. The functions I showed today is just the tip of the iceberg of what Matplotlib offers. If you're into it, definitely go check out their official website at matplotlib.org, and also Google GitHub. There are some really good articles there. I hope you enjoyed today's episode, and as always, have a nice day.